Okay, now we're going to talk about geometric modeling. The main thing that you need to know are how to find essentially distance formula and slope formula. If you know distance formula and slope formula, you are golden. Now the distance formula is on the formula sheet, but the slope formula is not. So you are going to have to know that piece of information. If they ever ask you to find the diameter of a shape that's on a coordinate plane, you will be using the distance formula to determine, let's change it up, let's go blue. You're going to use the distance formula to determine like the length of the shape. So if you have a triangle, you would have to do the distance formula on each of these lines, and then you would just, for perimeter, add all the sides. And it even reminds you on the formula sheet, the first thing they tell you is perimeter, add all the sides. For area, the same thing. If you have a rectangle, for example, you would need to find one side, the short side, and the long side, and then you could just do the area formula, which is multiply base times height. For the proving a parallelogram, there's a lot of different ways you could do it. You could do it by saying the opposite sides are the same, and so you would use distance formula 4 times and show that the opposite sides are the same measure. You could also do the slope formula and show that the opposite sides are parallel, meaning the opposite sides have the same slopes. You could use the midpoint formula and prove that the two diagonals have the same midpoint value. That'd probably be the fastest way to do it. If you're doing a rectangle, you would also, or you could actually just pick one of these, a rectangle, they form right angles. And the ways that we prove a rectangle is we find the slopes for each side, and if the slopes are those opposite reciprocals, meaning we change the sign and we flip the fraction, it's a rectangle. For a rhombus, you could do the distance formula 4 times and prove that all the sides are the same measure, not just opposite sides for the parallelogram, but all the sides. For diagonals, you could also say the diagonals form right angles. So if you only wanted to do the slopes of just the diagonals, if those two slopes are right angles, you've proven the rhombus. The square is the same thing. Not only do you have to do that the right angles, but also you need to show that at least the adjacent sides are also perpendicular. So you're going to be doing a whole lot more for slope. Or for square. Here's some reminders about slope. Well, how do you do slope? Typically, slope is taught in middle school. All you're doing is you're subtracting the y's divided by subtracting the x's. So if they have 2 points, here's our 2 points, 1, 2, and 3, 5. All you do is you subtract the points. They did 5 minus 2. So first they subtracted the y's. I think 5 minus 2 is 3. And then they subtracted the x's. 3 minus 1 is 2. That's slope. Midpoint, you guys really know midpoint because I drilled it into your head. Remember, you did like 50 problems in one day on midpoint. It's like add the x, divide by 2, add the y, divide by 2, add the x, divide by 2, add the y, divide by 2. That's all you're doing. That formula is not on the formula sheet. You do have to remember that midpoint. Makes sense. If you have $10, 10 divided by 2 is 5. That's the midpoint of how much money you have. So all you're doing is you're finding out what's the average of these 2-point values. Directed line segment. You will likely see at least one directed line segment just because it's on the formula sheet, and this would be the unit that you would get it. The formula sheet has 2 formulas that they use. The formula that I taught you to use is the first one, bx1 plus ax2. So b times whatever your first x value is, times plus a times whatever your second one is, divided by b plus a. It's kind of like midpoint formula where you do something with the x's first and then you do something with the y's. So now I've got b, y1, a, y2, divided by b plus a. I really hope you get a directed line segment, at least one of them, because it's so easy. The hardest part is figuring out what is the b and a. So how do we look at it? That's why I kind of like this picture. Here it says if something's in the ratio of 2 to 3, that's kind of what we like. We like ratios. That first value is just going to be your A, and your second value is going to be your B. But if you get something like this, where it says like 3/5 the distance, don't be like some kids and being like, oh, 3 is my A and 5 is my B. That's not correct. You're going to want to draw a picture. That's what I used here. You're going to draw a sketch. If it's 3/5, I'm going to have a line. And I know from, 3rd grade that fifths means 1, 2, 3, 4, that you have 5 sections. So if you need to go down 3 of the sections, 1, 2, 3, here's where my point would be. So how many are on this side? 3 are on this side, 2 are on this side. So the hardest thing directed line segment is knowing the B and the A. If it says ratio, even if it has a fraction, but it uses the term ratio, it's cut and dry. The first number is always your A, the second number is always your B. If it doesn't say ratio and it gives you a fraction and it does not say ratio, you have to determine what those values are. So in this case, what we're going to do is just plug it in. We know our B here is 2. Our first x value, it does matter the order, is 3. So here we've got 2 times 3. Our A value is 2. Our second x value right here is 6. And then we're going to add 3 plus 2 is 5. So we know 2 times 3 is 6. 2 times 6 is 12. And when I add it up, then jumping all the way down here, my x coordinate is 18 divided by 5. You would not need to reduce that fraction. We're going to do the same thing over here. Our B value is 2. Our first y value is 4. Our A value is 3. And our second y value is 10. And like we said, when we add it all up, we get 5. So here's 8. 2 times 4 is 8. 3 times 10 is 30. That gives us 38 fifths. And really, I should have written them together, so I will now. There you go. Ta-da! Again, it's not hard plugging the stuff in. The only things you got to remember is use the first point for x1, y1, use the second point for x2, y2. The trickiest part is what is the A and B. If it says ratio, you're perfect. You don't have to do anything else. The first one's A, the second one's B. If it doesn't say ratio, you're going to have to determine those A and B values. Okay, here we go. Next one. Distance formula. So the distance formula is on the formula sheet, but let's say that you want to do the IRCAC. So I'm going to demonstrate the IRCAC for this. Here it wants us to find the perimeter and area of this rectangle. Ooh, I made a typo. This should be parentheses here. I must have forgotten the shift. So I know that I'm going to have to define the perimeter. This is my cheating way to do it. You don't have to do it 4 times. Just write A, B, C, D. We know that in a rectangle, the opposite sides are congruent. So really, we only have to find AB, because that's going to give us CD, and we only have to find BC. So I'm going to find AB first. Here's the math hack. First point goes on top, second point goes on the bottom. That's what it said. Write one point on top of the other. Then write a subtraction sign next to the bottom point. Subtraction sign next to the bottom point. Then it says change, change, change. So I'm going to go and change the subtraction sign to a plus sign and change the sign of each bottom point. So the 3 becomes a negative, the 2 becomes a negative. Then it says to add the points going down. You can also just do the distance formula for sure. Add the points going down. Negative 3 plus negative 3 is negative 6. 0 plus negative 2 is negative 2. Then it says to square each number, then add across. So I've got negative 6 squared is 36. Negative 2 squared is 4. Add across, that's going to give me my 40. And then you always end with the square root sign. That's it. Take the square root. So now we know that this length right here is the square root of 40. And again, because it's a rectangle, we know that this side right here is also the square root of 40. Now we're going to do the same thing for BC. I'm not going to keep switching colors. I'm just going to go ahead and do it. BC, I'm going to write 3, 2 on top. I'm going to write 4, negative 1 on the bottom. Subtracting, change, change, change. 3 plus negative 4 is negative 1 squared. It's positive 1. 2 plus 1 is 3. 3 squared is 9. Add it up. 10. Draw your square root. So now we know this side is the square root of 10. So I made these numbers up, so it's definitely not pretty. To find the perimeter, we're just adding all those numbers up. So for the perimeter, you could just get a decimal. You could definitely do it that way. Or if you want to be fancy, the answer would be 2 square roots of 40, because there's 2 square roots of 40, plus 2 square roots of 10. But most of you most likely will just get the answer as a decimal, and that's totally fine. So if we did do that, we would do 2 square root 40. Just don't forget, if you're using a calculator like this, you have to close the parentheses. Plus 2 square roots of 10. Syntax error. See, even I screwed up. What am I saying? 2 square roots 40. Oh, I'm in a different mode. I'm not going to give you the decimal. But anyway, that's what you could do. For the area, though, the area, you're going to multiply these two sides together. So basically, we're going to have the square root of 40 times the square root of 10. Square root of 40 times the square root of 10, all we do is multiply 40 times 10, which is 400. And then to take the square root of 400, you're going to get 20. You also, I actually should have reduced this now that I think about this. This should have been 4 square roots of 10. But you won't have a problem that detailed on your, well, I can't say. I doubt you'll have a problem this detailed on the final, only because this deals with radicals, which is more of a skill from freshman year than now. So that's more becoming an algebra question. But, all right, next question, because that took forever. You need to go back? We good? Okay. And then 6 square roots of 10 is a lot easier to put in a calculator. Nope, let me just change my mode. 6 square root 10. 18.97 would be the perimeter. All right, here's our next one. Vertices of quadrilateral John are such and such. Use coordinate geometry to prove that John is a parallelogram. I am just going to use the midpoint formula because that's the quickest way. You only have to do it twice. So the midpoint formula says that if the diagonals bisect each other, so if the middle of JH is the same as the middle of ON, then we're golden. So we're going to do JH, ON, and we're doing midpoint. So how do we do midpoint? Add the x, divide by 2. Add the y, divide by 2. So I'm going to add -3 plus 5, because I'm doing JH, dividing by 2 gives us 2 divided by 2, which gives us 1. So our first x coordinate is 1. Do the same thing for the y's. Our y is 1 for a J. Our y is 7 for H. 8 divided by 2 reduces to 4. So we got 1, 4. So now if the midpoint of ON is also 1, 4, then we've proven it's a parallelogram without doing anything else that's fancy. So we've got 3 plus -1 divided by 2. That's going to give you 2 divided by 2, which equals 1. So far, so good. Now we're going to do the y's. O is 3. N is 5. That's plus sign 5. Which gives us 8 over 2, which gives us 4. Now, in theory, you need to say, because the diagonals bisect each other, John is a parallelogram. And this symbol right here is the sign for a parallelogram. Drawing a quadrilateral with 2 lines. So that's it. You also could have done slopes. We could have done the slope 4 times. We could have done distance formula. But the fastest way to prove a parallelogram is the diagonals share the same midpoint. Leo rides his bike 8 kilometers south and then 12 kilometers east. How far is he from the starting point? So here's Leo, 9 south. Then from there, he's going 12 east. How far is he? Well, it'd be very tempting to do 9 plus 12, but nope. We actually are doing Pythagorean theorem. Pythagorean theorem is on the formula sheet. It's on the top of the second column. So we're going to do a squared plus b squared equals c squared. So you've got 9 squared plus 12 squared equals c squared. 81 plus plus 144 equals c squared. And I'm not doing any more of that math. Out the calculator. 225. Oh, I knew that. Equals c squared. Take the square root, and I think it's 15. Yeah. So he is actually 15 meters away. So sometimes you think like, oh, it can't, you know, how can something, a large number, fit in like a box? Because if this is a rectangle, you would think that the biggest thing that could fit inside is 12. But don't forget the diagonals. Okay, so he's not 21 miles away. You didn't do 9 plus 12. You did the shortest distance between 2 points, which is the Pythagorean theorem. We got that line. Or technically the longest side of a finished rectangle is that also. We good? Oh, this is a trick question. A soccer field is a rectangle 90 meters by 120 meters long. I have no idea if that's true, but we'll just use it for this problem. Here's our 90. Here's our 120. It says the coach asks the players to run the longest distance from one corner of the field to another corner. How far did they run? Well, some of you might see, well, from here to here is 90, so, and here to here is 120. So the longest distance they ran was 120. But you would be wrong. That's not the case. Yes, 120 is the longest between this corner and this corner, but they could also run the diagonal. So don't just think, oh, 90 or 120. There's always that diagonal, and that's where the Pythagorean theorem comes in again. So we've got 90 squared plus 120 squared equals this diagonal, which is x squared. This is 8100 plus 1400, well, 14,400 plus x squared. This is going to give us 22,500. And take the square root of both sides. And they ran 150 feet. Okay, so some kids be like, oh yeah, 120 meters, or not feet, meters. 150 meters. But even though it's a rectangle, there is that hidden diagonal that the soccer players actually ran. They ran from this corner all the way over here. That's the longest distance that they could have run. It was 150 meters. All right, lovies, that's it. Yay!